It is with great pleasure for me to introduce Cathy. She's data-driven digital technology leader, formerly at Takeda and soon to be at somewhere else. Cathy has been a senior technology leader for 20 plus years, driving digital transformation across the life sciences at Takeda, J&J, and Pfizer. She led data technology initiatives across the biopharmaceutical and MedTech value chains. Currently advises on using trusted data, AI, and automation to accelerate R&D and enable the lab of the future. So today, Cathy will be speaking about from data to decisions, how data, AI, and automation are reshaping life sciences. Thank you, Cathy.
Is that working now? Okay. Thank you. It's a great honor to be here and speaking with you. So good afternoon, everyone. I want to start with a simple idea. The future of life science will not be shaped by AI alone. It will be shaped by the quality of our decisions. And the quality of those decisions will depend on whether we can turn data into trust and trust into actions. Over the last 20 plus years, I have had the privilege of leading digital transformation across regulated environments. And I've seen one lesson repeatedly itself again and again. Technology creates value only when it helps people navigate complexity with greater clarity, confidence, and speed. That is why I think about AI and technology as a lighthouse. A lighthouse does not remove the storm. It does not flatten the ocean. And it certainly does not eliminate risk. What it does is more important. It helps leaders see through complexity. It helps teams navigate uncertainty. And it helps people apply judgment where it matters most. That, to me, is the role of data, AI, and automation in life science. But the lighthouse is only useful when it builds on something strong. A strong base, a reliable structure, and a beam you can trust. And in our world, the foundation is not an abstract. It's core capability, trusted data, strong cybersecurity, AI fluency, and the governance that meets global standard. From there, we build upwards: productivity, process reinvention, and ultimately, patient impact. So today, I will talk about the journey from data to decision and how data, AI, and automation are reshaping life science in a way that is practical, scalable, and deeply human. I'd like you to imagine a lab that is completely quiet. No one is searching for a latest spreadsheet. No one is cutting and pasting results from one system to another. No one is waiting for context to arrive from another function, another team, and another platform. And yet, the work is moving faster than ever. Experiments are still running, data is still flowing, decisions is still being made. But the environment behaves differently. Protocols are not a static document. They are living digital objects. Data is captured once with context. Automation handles repetitive work. Models help propose the next best move. Scientists spend more time where they create the most value. Interpretation, judgment, and discovery. This is the future many of us can already see. A lab defined not by walls, but by the seamless flow of knowledge, connected workflow, and context-rich data. In silico models propose the path forward. Experiments generate new evidence, and that evidence retrain the model in a closed loop. A unified data fabric becomes essential because the work only accelerates when scientific and operational data move with context. That future is not about replacing people. It's about giving people a better light to work by. That is what the Lighthouse does. It helps us see what matters sooner. So raise your hands. Let me ask you two quick questions, show of hand. How many of you believe some version of that future is possible in the next 3 to 5 years? Now keep your hands up if you believe your current data environments are fully ready for it. That gap between the future we can imagine and the foundation we already have is the story of this moment. Because many of us can see the beam, but few of us have built the lighthouse. So now here is a surprising truth I want to anchor on today. The biggest AI problem in life science is not the model, it's mistrust in data. Not lack of ambition, not lack of tools, not lack of pilots, mistrust in data. We hear that over again in the morning as well. We're living in a time of extraordinary AI capability. Models can summarize, reason, generate, search, orchestrate, and increasingly act. But when AI stalls, the problem is rarely the algorithm. It's this, it's too many sources of truth, too much manual reconciliation, too little lineage, too little metadata, too much ambiguity around what a result means, where it came from, and whether anyone should trust it. And in a regulated industry, trust is not a soft concept. Trust is a provenance. Trust is a validation. Trust is a auditability. Trust is explainability. And trust is whether a scientist, a quality leader, or a regulator can rely on the output. So if we want AI to scale, we have to stop talking about AI as a layer floating about enterprise. It sits on top of data. Whether the data is fragmented, weakly governed, poorly contextualized, and difficult to reuse, AI does not scale. It demos well, it highlights well, but it doesn't transform the business. If the signal is weak, the light does not travel far. Let me make this real with a story many of you will recognize. A team invests in a beautiful automated workflow. Demo day is perfect. Place move, robot dance, data flows, everyone applauds. It looks like the future. A new assay, a new plate format, a new review requirement, an extra incubation step, a different handoff between teams. And suddenly, the system is difficult to reconfigure. Only a few people know how to change it. Update takes weeks. Data flow begins to break. Scientists quietly create workarounds. And eventually, people drift back to manual work. Not because the vision was wrong, because the system was brittle. That is one of the clearest differences between isolated automation and a software-defined science. In brittle automation, the workflow works only as long as nothing changes. But in a stronger digital model, change is expected. The protocol is computable. The workflow is reusable. The data carries context. The system adapts without being rebuilt every time the science evolves. So when a good pilot stalls, the problem is usually not a creativity. It is architecture, it is semantics, it is governance, and it's adoption. Let's stay with the lighthouse metaphor for a moment. A lighthouse is only useful because it stands on a strong foundation. No one looks at a lighthouse and say, the beam is enough, forget the rock, forget engineering, forget the structure. And yet, this is exactly how many organizations approach AI. They focus on the visible beam, the model, the tool, the pilot, while under-investing in an invisible foundation that makes it reliable. In life science, the foundation is clear. Core capabilities, trusted data, strong cybersecurity, AI fluency, governance that meets global standard. This is what allows technology to guide rather than confuse, to accelerate rather than amplify risks, to strengthen judgment rather than replace it. And this foundation is not just technical, it's organizational. It includes how teams work, how decisions are made, how data is owned, how quality is monitored, how people are trained. Without that base, AI becomes fragile. With it, AI becomes dependable. One reason this conversation gets stuck is that people hear the phrase AI-ready data and imagine an impossible goal. Perfect data, everywhere, all at once. That's not the goal. AI-ready is not clean data everywhere. It's a fit-for-purpose data with enough structure, context, and control to support the decision you're trying to improve. That means a few things. The right metadata is attached. Lineage is visible. Access is governed. Definitions are consistent enough for people and the system to interpret the same thing the same way. And this is where semantic becomes crucial. A unified data fabric is not just a storage concept, it's a meaning concept. It's what lets scientific data, workflow data, operational data, and knowledge data come together in a form that can be reused. Your own lab of tomorrow materials frame the future with ontology, knowledge graph, qualification-based access, and normalized scientific and operational context. So when I say AI-ready, I don't mean polished. I mean reusable, traceable, governed, reliable enough to act on. One of the biggest mistakes organizations make is rushing to the newest visible layer of AI. I hope you all agree. They start with a generative AI because it's exciting. Agentic AI because it sounds transformative. But real capability is built in layers. Use predictive AI when you need forecasting and optimization. Use generative AI when you need synthesis, drafting, and reasoning support. Use agents when you need work to move across systems and work processes. And use more autonomous models only when operational control are mature enough to support them. This is why the right question is not, how do we use more AI? The right question is, what business problem are we trying to solve? And what type of AI actually fits that problem? Because when organizations skip that logic, AI becomes expensive theater. When they get it right, AI becomes capability. Once the foundation is in place, the operating model changes. The strongest pattern I see is this. In silico first, models propose a path forward. Closed-loop learning. Automation and experimentation generates new evidence. Unified data fabric. That evidence flows back with context, so the next decision becomes better than the last one. This is the shift from isolated digital initiative to a learning system. And that matters because AI is changing not only the pace of the discovery, but the nature of the discovery. We're moving from isolated, intuition-driven work towards more continuous, data-driven learning. From disconnected tool towards orchestrated workflows, from reporting after the fact towards insight in motion. That is when the lighthouse becomes more than illumination. It becomes direction. Now let's come back to a vertical structure of the lighthouse. Once the foundation is strong, we build upward. The first level is productivity. This is where AI reduces friction in daily work. Summarization, drafting, synthesis, search, routine coordination, repetitive analysis. It gives people more time to apply their expertise when it matters most. The middle level is process reinvention. This is where AI starts to change the way core work happens across discovery, development, supply chain, quality, and commercial execution. Not just faster track, better flow, better orchestration, better decision. And on top of is the patient impact. That is the reason any of this matters. Better workflow, more precise decisions, faster action, better outcomes, faster path from science to supply. If we stop at productivity, we save time. If we transform processes, we create value. But when these gains connect all the way to patient outcomes, we create purpose. That is the highest point of a lighthouse. One of the most important points to make is in a regulated industry is this. The future is not thousands of unchecked agents operating without supervision. The future is more intelligent systems with humans firmly in the loop. That is not a limitation. That is leadership. Because the real challenge is not just deploying intelligence, it's managing complexity, building guardrails, designing for interoperability, ensuring measurable value, knowing where autonomous is useful and where human review must remain. A lighthouse does not eliminate human responsibility. It sharpens it. It gives people better signal, earlier signal, more connected signal. But people still decide how to steer. So what should leaders do now? I would suggest a very practical roadmap. First, pick 2 or 3 high-value use cases. Not 20 pilots, not a slide full of possibilities. A short list of problems where better data, better workflow design, and the right AI can change outcomes. Second, build one trusted data product end-to-end. One workflow, one use case, one proof that data can move, context can stay attached, and decision can improve. Third, scale the capabilities underneath it. Semantics, lineage, governance, observability, adoption. This is where many organizations lose momentum because the work is not glamorous. But this is the work that turns pilot into platforms. your roadmap materials make the same point. Foundation first, then priority value, then full scale, then unlock potential, and more advanced agentic capability. That is how you build a lighthouse, not all at once, but layer by layer. So let me close. Where I began. A lighthouse does not remove complexity. It helps us navigate through it. That is what data, AI, and automation can do for life science, but only when the lighthouse is built well, only when the foundation is strong, only when the data is trusted, only when governance is real, only when people remain at the center. If we lead like this, AI becomes more than a tool. It becomes a source of clarity in complexity, a force multiplier for scientists, a force multiplier for operators, a force multiplier for decision quality, and ultimately a force multiplier for patient impact. So as you leave today, I invite you to ask 3 questions. Where does trust break down in our workflow today? Second, what one decision would improve if the right context arrived at the right time? Third, and what one use case is important enough to scale beyond pilot mode? Start there, start small, build trust, scale what works. That's how we move from data to decision. Thank you. Any questions?
Thank you, Cathy. So I have a question. I've always been a firm believer that humans will be even more critical to really help with a lot of this trust and really validating a lot of this data. Can you speak more to that a little bit more? Because I think a lot of scientists fear for their jobs, but I want to get your opinion on that because I think we're moving away from more of the operational work to more of the, what scientists are meant to do. It's like really think, right?
Yeah.
So maybe you want to bring your perspective. I think I know it already, but kind of elaborate on that further.
Sure, I agree with you, right? I do believe we cannot remove people because we're at the center, and we're the reason we need AI and everything else, right? And not only that, what I see the trend is, for the last 20 to 50 years, right? We always have a lack of enough developers to build a system for us. And the reason we have skilled agile from any agility we need to do is, organizing the resources so we can improve the productivity of the development team. Now we got agentic AI can do that for us. I think it will shift upstream. What that means is, if the agents can do the development work quickly for us, where's the bottleneck? It shifts up, right? How can you define the work, like the backlog, articulating what you need, what is the business problem? I think we need to shift that agile framework, help people to say how you define what you need, what should be the feature, how the flow really should look like. And people have the domain knowledge, understand the business problem. It's actually needed more. And it's more creative work, more meaningful work. I think people will be happier than doing those repetitive work. That's my thinking. Hopefully, you guys agree with it.
So I like what you were saying about the building trust that also came up during the panel.
Yeah.
Have you seen any areas where we should be on alert for the trust falling down or where there's been challenges? Because you said, well, if there's not trust, then people aren't going to use these things. So anything to look out for or really key points that you've seen in building that?
Yeah, I think the reason we don't trust the data because the data is not, we didn't get truly the AI-ready data. right? And the many things we need to do, as I mentioned, like ontologies, like photograph, all the different things and semantic layers need to be in place. But not only that, right? Like you're thinking about the previous data we have, I think a panel also mentioned that the scientists don't want to keep those negative data, right? Outliers, they're being removed. But we know now with AI, right? If you have those outliers, it will help the model to improve the performance, right? So those are the things I think Savannah also mentioned about, how can we turn the legacy data into a useful data so that we can have the closed loop. I don't think we have that yet. We have pointed data scattered all the different places. That's why we cannot trust, because we're scientists, right? We have to be logic and we have to be able to trust the data. But if data is not there, you cannot trust it. I think that's where it's not a people issue. Of course, there are people issue as well, right? So seeing, are you ready to change, right? Do you want to lead the change? Are you embracing the change? That need to be there as well. But at the same time, the foundation needs to be there. Thank you. Good question.
You mentioned governance and guardrails. My impression is that there's a lot of desire for AI, and that doesn't always come with those conversations around how do we structure it and how do we leverage it as opposed to the need to do so. Do you see actually AI potentially helping implement its own guardrails? Is there an option for that versus trying to always play catch up around what's being developed in the AI space and applying the guardrails afterwards?
Very good question. I actually agree with your idea. I think AI right now can help us to build the right guardrail in place as well. And we also need to make sure our AI vendors or providers to keep that in mind, right? And I already see there's some good AI models for cybersecurity. We also see AWS and even NVIDIA, they put Evolve's automatic as part of their model to help us. But I don't think that's enough in our regulated environment. We still have to see, what are the business outcome, what is the intended use we need, and to go from there, align with our quality regulatory leaders to make it right. But at the same time, right, we also need educating them so how they can go along with us with the velocity or speed we need. Yeah, I don't think anyone figured that out yet. We all, keep the right mindset and to move forward together. Yeah. Oh.
One last thing. Sorry, okay. I don't think I need a mic. Can you talk a little bit about the use case selection at the beginning of the process? Because if you select the wrong one, not only you won't be propelled for initiative, you could potentially derail. So what kind of consideration do you think about?
So that's $1 million question, right? So I think Shawanda, Sean, and Venu, and our Takeda colleagues can testimonize on this, right? So we actually, when we're trying to do it, we put how many, 200 to 400 use cases first? And yeah, so we got a lot, like 200 plus use cases, because there are so many possibilities, right? And then at the same time, it's not people don't want to be part of it, right? It's just don't know how to be part of it and how to make it a truly value. I still feel it should be the business problem first, right? What is the business problem you try to solve? And what is the business value outcome you're expecting? From there, and the value, and at the same time, I think this is a data digital technology AI team can help is, how long it take to achieve that, right? And that all together, I think a SAFE framework has the widget calculations to say, how you should prioritize that. And things may change a little bit. I think the framework still helps to make it as value-based control tower to prioritizing your business, use cases. I hope that makes sense to you. Yeah. Okay. Thank you.